So here what we're going to do is I'm going to teach you the method of half reactions to balance a chemical reaction. And then I have two examples that I'm going to work out. And then what we're going to do is I'm going to teach you a different method on the same reaction so you can see how the two methods sort of overlap in concept, but differ in their approaches to balancing the reaction. So I have my reaction over here, and I'm just going to go ahead and get started. But the first thing it says is identify the half reactions. Really, that means split the reactions up into what you think might be the oxidation and reduction products, okay, and reactants. So I'm just going to go like this. And it turns out you may not know what they are, but you're going to just split it up according to the elements that are present. So that's one of them. And the other one would be SO4 2 minus, making S2O3 2 minus, like that. Sulfate to thiosulfate. Now, the rules that you do next get applied to each half reaction, okay? And if I'm looking at aluminum and aluminum 3 plus, you balance everything plus H except H and O, and there's nothing else in here. There's no O, there's no H, so I'm all the way down to here in the rules. And so then the last thing is just to balance the charge with electrons. And so I have a 0 charge on the left, so I need 0 on the right. And this is generally how this works. Add to the more positive side. So aluminum is 3 plus, so and aluminum metal is 0, so I'm going to add the electrons over here. And that balances it out. That half reaction is balanced. Now what I have to do is I have to apply these rules to the sulfate thiosulfate reaction. Okay, so what I'm going to do is balance everything except H and O, and since I have two sulfurs in here, I'm going to put a 2 in front of the sulfate like this. The next thing I'm going to do is I'm going to balance oxygen with H2O. So now if you look over here, right, there's 8 oxygens, 2 times 4, but I have 3 oxygens here. So I have 8 oxygens, I have 3 oxygens, that means I need 5 H2Os like this. And that balances my oxygens. Now the order you do this in is very important because when you add the oxygens, you're adding hydrogens. And so now we're going to balance the hydrogens. Once we've added the hydrogens in the water, there's 10. So that means on the other side, I need 10 H pluses. And for this one, I have to balance charge again. So now notice what happens. I have a -2 here, and I have a 0 here. So overall, this is 2 minus. On the right, I'm going to add electrons to get that to balance. And it turns out that I'll need to have 10 electrons like this. And that will balance that half reaction. So, and you can see 10 minus 10 plus, right? That becomes 0. Oh, I'm sorry. I have 4 minus here, so I have to fix this. I did that wrong. I have 4 minus here and 10 plus here, so I actually need 8 electrons. Can't get my pen to work anymore. There we go. 8 electrons like that. So let's double check that I did my calculation correctly. Not sure that I did any more anyways. But I have 8 negative charges, right? And then I have 4 more. So that's -12. And then I have 10 pluses. So that's -2. So now the charge on the left and the right hand sides are balanced. Now, here's the difficult part. And if you remember early on, so not necessarily more difficult than the earlier part, but like numerically difficult part. Remember, what we're trying to do is get the electrons that leave this reaction to balance the electrons that are going into this reaction. I have an 8 here, and I have a 3 here. And so the closest I can get is by multiplying the top reaction by 3, or 8, sorry, and the bottom reaction by 3. So in order to do that, I'm going to go like this. I'm basically cross-multiplying the same way you find formulas for compounds. We're going to do that with the electrons in the half reaction. So I'm going to have 5 H2Os, right? But I'm going to be multiplying it by 3. So it's going to look like this. And I'm going to write it out. Maybe a little bit small, or erase some of this to give myself some room. I'm going to have 24 electrons plus, oops, sorry, I forgot the 4. 24 electrons. I'm going to have 30 hydrogens. I'm going to have 6 sulfates. And I'm going to have 3 thiosulfates. And I'm going to have 15 waters like this. Okay. Now, for the aluminum, I have to multiply that one by 8. So I'm going to write that one right below here. I'm going to have 8 aluminums. And then I'm going to have 3 times 8, 24 electrons. And then over here I'll have 8 aluminum metals like that. Now what you do is you cancel out stuff that's on both sides, and that add the rest together, keeping track of what's on the reactant side and the product side. So I'm going to write that down at the bottom. And then we're going to say I have 10 or 30 hydrogens plus 6 sulfates plus 8 aluminums makes 3 thiosulfates plus 8 aluminums plus 15 waters. So that reaction should be balanced in both mass and in charge. So what I'm going to do is a quick check. The quick check goes like this. I have 30 plus here. I have minus 12 here. So that's a total of 18 positive charges that I have. Now, on the right-hand side, I have 6 minuses. Because of the 3 times minus 2, and then I have 24 positives. If I add those together, I get 18 positive. Now, generally speaking, if you can get the charges to balance, it means the mass is balanced as well, but you should really double check and count, okay? So this is a completely balanced redox reaction. It's balanced both in charge and in mass. And I think you can see why that this kind of method is important in doing the redox balancing, because it would be almost impossible to come up with this without some sort of method, okay? These reactions are the same reactions that you'll find in batteries and fuel cell engines that create electricity from gasoline rather than directly converting gasoline to carbon dioxide. So these are really technologically important reactions, battery reactions, anything like that. All right, so let's do a couple of examples. And we're going to do this reaction. I have the reaction of iodite to form periodate, and then also at the same time manganese is turning into manganese 2+. So we're going to split the half reactions, and I think we'll be able to do a little bit on each side and then combine it at the bottom. Okay, so I'm going to go like this: IO2 minus, and then I'm going to draw an arrow and leave myself a little room, IO4 minus, and then I'm going to have MnO4 minus, and that makes Mn2 plus. Okay, so what I'm going to do is take a little bit more systematic approach and show you each step. Now, this is not necessarily the way you'll do it once you become practiced at it, but it is a good way to start. And this is what I'm going to do. These are going to be the half reaction steps along the left-hand side over here. Okay. And what I'm going to do now is I'm going to number these as 1, 2, 3, 4. And these are the 4 steps that you have to do for each half reaction. So, 1, right? Balance everything, right, except oxygen and hydrogen. And it's already balanced in iodine, so I'm just going to cross that off the list, and then I'm going to go 2. So what's the next thing? The next thing is to add H2O to balance my oxygens. So I have 4 oxygens over here on the right-hand side, right? And I have 2 oxygens over here. So what I'm going to add is I'm going to add 2 H2O on this side. So the third step, and you see what I'm doing, is I'm doing every step separately, but I'm going to keep a tally like this and add the left sides and the right sides when I'm done. So I have 4 hydrogens here. I have no hydrogens here. So what that means is in step 3, I'm going to add 4 H pluses like this. And then the last step is to add up your charges and figure which side you have to add the electrons to. So on this side, I have a total charge of -1. So I'm going to make a note of that. If I can get my pen to work. There we go. And on this side, I have a charge of +3. That's what -1 and 4 pluses give you. Now here's the thing. You have to make the left and right hand sides the same. You're not trying to make them 0. So what do I have to add to +3 to get to -1? And then this is where we're going to add 4 electrons like this. Now I can write everything out now. I'm just going to add it all up, and this is going to be my balanced half reaction. And remember, these circles, these are just to do the charge balancing. So now I have IO2 minus plus 2H2O make IO4 minus plus 4H plus that goes on top, nice, plus 4 electrons like that. And that's the balanced half reaction. And if you want to stop at this point and double check that the charge is balanced, you can do that, and you can see that the left charge and the right charge are the same. They're both -1, okay? And that's a good check. I mean, as you go along to check those things to make sure you're doing it right. Now I'm going to do the same thing for this reaction. For 1, I don't do it because I don't need to. Right? Manganese and manganese is balanced. Now I need to add the water. So for step 2, I'm going to add 4 H2Os on this side to balance the 4 oxygens that are in the permanganate. And then I'm going to add 3. I'm going to add hydrogens, and that's going to be 4 times 2, so it's 8 H pluses like this. Now, the right side is +2. The left side is +7. Because I have 8 pluses and a 8, sorry, I can't see that. I have 8 pluses and a minus, right? So now I need to add 5 electrons to make the left and right hand side balance. So I'm going to go 5E minus, right? Because they carry a negative charge. And then I can tally those up, and I'll have my balanced half reaction on the right hand side. So I have MnO4 minus plus 8H plus 5, I went over the line, oh well, electrons makes Mn2 plus 4H2O, like that. Now, I'm at the point in the steps. This is going to be 5, and 6. Okay, now this last step, I'll do that in the next example. But for now, we'll just sort of ignore that it's there. So here's what we're going to do. I have to look to see how many electrons are here and how many electrons are here. And you'll notice it's 4 and 5. So that means I'm going to multiply this reaction by 5. Let me do something real quick. I'll change the color. So I have 5 electrons here. So this I'm going to multiply by 5. And then I have different color. I'm trying to find a different color that shows up. I have 4 electrons here, so I'm going to take that whole reaction and I'm going to multiply it by 4, like that. And then I'll recombine the two, okay? So what I'm going to do then is I'll write 5 IO2s. Oops. I want to stick with the color code here. 5 IO2 minuses plus 10 H2Os, and then an arrow to 5 IO4 minuses plus 20 H plus 20 electrons, like that. And then I'm going to do the next line. It'll be the other reaction multiplied out, so it's going to be 4 times, right, MnO4, so 4 MnO4s. I'm going to write it a little bit higher because I do still need to combine them. Plus 32H plus 20 electrons makes, and then it's going to be 4 Mn2 plus 16 H2Os, like that. So top reaction multiplied by 5, or sorry, left reaction multiplied by 5 to give me the blue top reaction, right reaction multiplied 4 to give me the green lower reaction. And now what I get to do is I get to get ready to add these two things together. Now before I add them, I'm going to cancel out things that are redundant. So you'll notice, for example, there's 20 hydrogens over here and 32 hydrogens over here. So what I get to do is cancel all 20 of these out and then cancel 20 here, so that leaves me with 12 hydrogens. And maybe a different color would show up better, but I don't really have much choices. I'll just do this, and that leaves me with 20 or 12 hydrogens. Keep doing that. These will have all gone away then. The 20 electrons go away. Now, you notice I have right here 16 waters, and over here I have 10 waters. So I'm going to be able to cancel these all out, and then I'll be left with 6 here, like this. Now that should take care of all the redundancy in the two half reactions, and then I can rewrite the final reaction. And that will be the balanced redox reaction, so I'll go back to red for that. I'm going to draw my line like this, and then I'm just going to write everything down. So I have 4 MnO4 minus plus 5 IO2 minus plus 12H plus, and then everything else is gone, right? So I'm going to go arrow, and then I have 5 IO4 minus plus 4 Mn2 plus 6 H2O, and then everything else is gone. And again, the check for this is to go through the charges and make sure they add to the same overall charge. And in this case, it would be, for example, 5 times minus 1 and 4 times 2, right? So this is 8. This is 5 you're subtracting, so it should be 3 on this side, on the right. And then 4 plus 5 is 9, right? negative, but 12 plus makes it plus 3 on the left side. So it turns out that you can do a charge balance, and you should check that on your own. I went through it fairly quickly on the charge balance. You should check that on your own so that you can agree with me on that. Or tell me I'm wrong in chat, or text me and let me know I'm wrong. Anyways, so that's the half reaction method of balancing reactions. One last thing I wanted to say about this, and I should have mentioned it earlier. This top reaction, or this reaction here, you notice that there's electrons on the right. That's the loss of electrons. So this is my oxidation half reaction, and this is my reduction half reaction, because it's consuming electrons on the left-hand side. So a couple of just things to remember when you do this, right? I have one more example. I know these are taking a long time, but usually students want more examples rather than fewer. Is that first thing you do is you split the half reactions. And then it's the same 4 steps for both sides, left and right, same 4 steps. Then you cross multiply to get the charges to balance. And then you add them together. But when you do that, you make sure you cancel out all the extra stuff before you do that, or this bottom equation is just crazy long, and then you'll have to rewrite it anyways, okay? Okay, so I partially worked this one out already. I did the steps, the 1, 2, 3, and 4. Again, step 1 gets skipped often, so I skipped it in this one. And then I added my waters to balance my oxygens. Then I added my hydrogens to balance my hydrogens, my H pluses. And then I added electrons to balance charge, okay? And this one is supposed to be done in basic conditions, but in fact, when we're doing basic conditions, everything's the same as acidic conditions until we get to the last reaction, and then we modify it to reflect acidic condition or basic conditions. As it is, this reaction reflects acidic conditions because I have H pluses in the reactions from the hydrogen ions of an acid. So I'm at that step where I cross multiply, right? And the reason I stopped on this one is you don't always have to cross multiply, because that often leads to big numbers, like it's been doing in some of these reactions. In this one, you'll notice I have a 3 and I have a 6. So all I need to do is multiply the left reaction by 2, and I can leave the right reaction alone. So I'm going to multiply this one by 2, and then I'm going to get 2, I'll write that one on top, 2 aluminums plus 4 H2Os. Let me write it a little bit higher. 2 aluminums plus 4 H2O makes 2 aluminum Al2O minuses, sorry. ALO2 minuses, there we go. 8 H pluses plus 6 electrons, like that. And then I just write the other reaction over again. So it's going to be NO2 minus plus 7H plus 6 electrons makes NH3 plus 2H2O. And I did also want to point out one other thing in this reaction, which was different than what you've seen in the earlier ones. There was actually hydrogen in this product, so when I added these hydrogens to it, I needed to add all of these together to get the 7, okay? So I have these two reactions. I can cancel out the extra stuff, so like the electrons here and here, 2 of the waters and 2 of the waters over here, and the H pluses, there's 8 here and 7 here, okay? So this is what we're going to do. We're going to go ahead and rewrite the reaction by adding it together, but before we do that, we'll just go ahead and cancel some stuff out. So the 6 electrons go away. And by the way, if your electrons don't cancel, remember you set it up for the electrons to cancel. You should really go back and look at what you did. Okay, so I'm going to get rid of that. I'll put a 2 here. I'll get rid of that, and I'll put a 1 here. And then I think I've gotten rid of all my extras, and so I'm going to go 2 aluminum plus 2H2O plus NO2 minus makes 2AlO2 minus plus NH3 plus 1H plus, like this. Now, here's the thing. If it's going to be under basic conditions, then what we do is we do this. We're going to add this reaction at the bottom so that the H pluses cancel out, and then we'll see what happens after we add it together. So it's H plus OH minus makes H2O. In this reaction, right, I'm going to put H plus OH minus on this side, and on the right side I'm going to add H2O, like that. Now, had there been two of these, I would have doubled this reaction. But look what happens here, right? The effect is I've added OH on the left and H2O on the right, and now I have an extra water here to cancel out from the neutralization. So I'm going to go do like that. And then my final reaction is 2Al plus H2O plus NO2 minus plus OH minus makes 2AlO2 minus plus NH3, like that. And because this has the OH in it, it reflects how the reaction would look if it were done under basic conditions.